Okay, I'm going to record this so that you guys can get help with this online homework question that seems to be troubling a lot of people. It says, a waitress believes the distribution of her tips is slightly skewed to the left with a mean, so mu is 820 and the standard deviation is 640, but this model is not normally distributed. It says she usually works on about 50 parties, so now they're telling me n is equal to 50 over a weekend of work. So because this number n is greater than or equal to 30, we can apply the normal model. So we would want to create a model here before we even approach this problem that looks something like this. So our model is going to be 820 as our mean with 640 divided by the square root of 50 as our standard deviation. And I'm going to go ahead and compute that because usually I'm looking at my packet and I have the answers in front of me, but I want to make sure that we're all on the same page. So our normal model here is actually going to be a mean of $8.20 and a standard deviation. I'm going to take this out to 4 decimal places so that nothing gets impacted by that. It's 9051 out to 4 decimal places. So this is the model that we just created. I'm going to put a little box around it, okay? We're going to use this normal model to solve both parts A and B because they both refer to weekends when she's got 50 parties. So we're going to say for part A, this is very similar to take-home quiz, similar to take-home quiz 8, number 2. However, over the years, I have edited the language in Take Home Quiz 8, number 2 to be a little bit easier for people to compute. So that's why this is a little bit more challenging. This says estimate the probability she will earn at least 500. So at least 500 is what we want her to earn. But if we recall, we are given that she makes $820, or sorry, $8.20 per table, right? She doesn't make that in a weekend. So we need to figure out what this means in terms of the average for each table. So we want to know what is the probability that the average for the table, and at least means greater than or equal to, so will be greater than or equal to 500 over the number of tables she serves that weekend, which is n, 50 in this case. So remember that I'm taking the value they provide me and dividing by the sample size. So you take the value they give you as the dollar amount and divide by the sample size as well. We are now going to be solving this problem. What is the probability that the mean is, and this is a nice one, greater than or equal to 10? So if they say greater than or equal to, then I've just been provided my lower bound, and I'm going to go right into normal CDF, and I'm going to take 10 as my lower bound, 1E99 as my upper bound, 820 as my mean, and 0.9051 as my standard deviation. Once I put this in the calculator, so we go to second bars, option number 2, 10 is my lower bound, 1 second comma, 99 is my upper bound, 8.2 and 0.9051. If I paste that and find my answer, I get 0.0234. Okay, and it says 4 decimal places as needed, so that's our answer. Now for part B. How much does she earn on the best 5%? Okay, so first of all, they've now given us the percent. So this is going to be an inverse norm problem. And it's our job to determine if we're given the percent to the right or the percent to the left. So best 5% is the same as, oops, that was ugly, is the same as talking about the top 5%, which means that if we subtract from 100, what we have on the left is the bottom 95%. So this would be an inverse norm problem where I put my percent as a decimal first, the mean of 820 and the standard deviation of 0.9051, and we figure out what our dollar amount is for each individual table. So I'm going to go to inverse norm, which again was the second VARS menu. I'm putting in all my values here, and I'm going to get 9, 6, let's do 4 decimal places just to be safe. 8, 8, okay? So this is a dollar amount, so eventually we'll round to 2 decimal places, as I'm assuming the answer asks. But the trick about this is that this number is per table. So what we would really want to do here is take our answer, so the final answer is going to be that dollar amount, 888, times the number of tables she served, which is 50. So 9.6123 times 50. And I get $484.44 as the final answer. So this here is the final answer for part B. Here, the first star up here is the final answer for part A. But the very first thing we needed to do was to compute this normal model first, right? So figure out what model we're looking at and then go ahead and approach those problems from there. Best of luck. I'm going to post this to Canvas so everybody has help.